Imagining Jupiter ignited. Look up at the night sky. See Jupiter? It's big and bright, a majestic gas giant. Now imagine it changing. It starts to glow with an internal fire, a light that rivals the sun's. Our solar system would have 2 suns. This is a captivating thought experiment. Can Jupiter in reality become a star? Let's explore the cosmos and find out. Right now, Jupiter shines by reflecting sunlight. To become a star, it needs to generate its own light. Stars are massive furnaces powered by nuclear fusion in their cores. They fuse hydrogen into helium, releasing tremendous energy in the process. This energy makes them shine brightly. Jupiter, while huge, is far too small to kickstart this process. But what if, just for fun, we imagine that Jupiter could become a star? What would it be like? Would our solar system transform into a binary star system, like those we observe across the universe? The implications are fascinating, both for Earth and for the cosmic dance of planets around our sun. Let's delve into the science of stars, comparing Jupiter's characteristics with these celestial giants, and explore what conditions are needed for such a remarkable transformation to occur. Jupiter is a giant, no doubt. It dwarfs all other planets in our solar system combined, but compared to the Sun, our actual star, Jupiter is a mere speck. It's like comparing a basketball to a stadium. The Sun makes up over 99% of our solar system's mass. Jupiter? Well, it's a lightweight in comparison. Stars are defined by their immense size and mass. This massive bulk creates intense gravity within their cores, squeezing hydrogen atoms together so tightly that they fuse, releasing the energy that makes them shine. Jupiter, while large, simply doesn't have the mass to create this kind of pressure. Furthermore, the composition of Jupiter differs from a star. While Jupiter is primarily hydrogen and helium, much like our Sun, it lacks the crucial density for sustained nuclear fusion. Stars are like incredibly dense furnaces, while Jupiter is more like a fluffy gas ball. To ignite, Jupiter would need a dramatic increase in mass, something on the order of 80 times its current size. Only then could its gravity ignite the nuclear furnace necessary for starhood. And even if it somehow magically gained this mass, the kind of star it would become wouldn't be nearly as grand as our Sun. Let's dive into the heart of a star, where nuclear fusion happens. Hydrogen atoms collide and fuse to form helium. This fusion releases energy, making stars shine. For Jupiter to become a star, it needs 80 times more mass. Even absorbing all solar system bodies wouldn't be enough. So, Jupiter remains a planet, the largest in our solar system. Imagine for a moment, against all odds, that Jupiter did ignite, transforming into a star. Our familiar solar system would become a binary star system, with 2 suns gracing our sky. The cosmic dance of planets would change dramatically, influenced by the gravitational pull of 2 stars instead of 1. The orbits of planets, including Earth, would become more complex, perhaps even chaotic. Instead of neatly circling a single sun, planets would be tugged in different directions by the competing gravitational forces. Some planets might be ejected from the solar system entirely, flung into the vast emptiness of interstellar space. The stability of the asteroid belt, a region between Mars and Jupiter, teeming with rocky debris, would be thrown into disarray. Asteroids, nudged by the gravitational dance of 2 suns, might be sent hurtling towards the inner solar system, posing a potential threat to Earth and other planets. The concept of a habitable zone, the region around a star where conditions are just right for liquid water to exist on a planet's surface, would also need to be redefined. With 2 sources of heat and light, the habitable zone would be a more complex and dynamic region, potentially shifting over time as the stars orbited each other. Imagine for a moment, against all odds, that Jupiter did ignite, transforming into a star. Our solar system would become a binary star system, with 2 suns gracing our sky. The cosmic dance of planets would change dramatically, influenced by the gravitational pull of 2 stars. The orbits of planets, including Earth, would become more complex, perhaps even chaotic. Instead of neatly circling a single sun, planets would be tugged in different directions by the competing gravitational forces. Some planets might be ejected from the solar system entirely, flung into the vast emptiness of interstellar space. The stability of the asteroid belt, a region between Mars and Jupiter teeming with rocky debris, would be thrown into disarray. Asteroids, nudged by the gravitational dance of 2 suns, might be sent hurtling towards the inner solar system, posing a potential threat to Earth and other planets. The concept of a habitable zone, the region around a star where conditions are just right for liquid water to exist on a planet's surface, would also need to be redefined. With two sources of heat and light, the habitable zone would be a more complex and dynamic region, potentially shifting over time as the stars orbited each other. Let's focus on our home planet, Earth. How would a second sun in the sky affect life as we know it? The most immediate impact would be the change in daylight. We would experience day and night cycles much differently, potentially with 2 sunrises and 2 sunsets each day, depending on the positions of the suns in the sky. The amount of solar energy reaching Earth would also increase, potentially leading to a warmer planet overall. This might sound pleasant, but even a slight increase in global temperature could have significant consequences, impacting weather patterns, ice caps, and sea levels. The increased radiation from 2 suns could also pose challenges for life. While our atmosphere provides a protective shield, prolonged exposure to higher levels of ultraviolet radiation could have detrimental effects on living organisms, potentially leading to mutations and an increase in skin cancer rates. However, life is remarkably adaptable. Just as organisms on Earth have evolved to thrive in diverse and challenging environments, life might find a way to flourish even under the glow of 2 suns. Perhaps new life forms would emerge, uniquely adapted to the altered conditions of a binary star system. The transformation of Jupiter into a star wouldn't just affect Earth, the entire solar system would feel its impact. The outer planets, Saturn, Uranus, and Neptune, would experience the most dramatic changes, their orbits significantly altered by the gravitational pull of a second sun. Saturn's magnificent rings, composed of ice and rock particles, held in a delicate balance by gravity, might be disrupted. The ring system could become warped, its particles scattered or pulled in different directions, forever altering its iconic appearance. The icy giants, Uranus and Neptune, might experience even more dramatic consequences. Their orbits, already far more elliptical than the inner planets, could become highly unstable, potentially leading to collisions with other celestial objects, or even ejection from the solar system. The asteroid belt, a region of rocky remnants from the early solar system, would also be in for a tumultuous ride. The gravitational tug-of-war between 2 suns could send asteroids careening in all directions, increasing the risk of impacts on planets and moons. In conclusion, the idea of Jupiter transforming into a star is a captivating thought experiment, sparking our imaginations and prompting us to contemplate the wonders and complexities of the cosmos. However, the reality is that such an event is highly improbable. Jupiter, despite its massive size, simply lacks the necessary mass to ignite the nuclear furnace required for starhood. The laws of physics, as we understand them, dictate that Jupiter is destined to remain a planet, a gas giant that reigns supreme among its planetary siblings, but falls far short of achieving stellar status. Nevertheless, the exploration of this hypothetical scenario highlights the delicate balance of forces that govern our solar system, and the profound implications that even a slight alteration to this balance could have on the planets and the potential for life as we know it. It serves as a reminder of the vastness and mystery of the universe where countless wonders await our discovery.